Okay, so these are the problems for the quick check for today's assignment, November the 17th, where you're supposed to use models to add mixed numbers. I want to read the problem. These are problems 4 and 5. I think somebody needed help on this, so it says Dara is making granola bars. The recipe calls for 1 and 2/3 cups of brown sugar for the bars and 1 and 1/3 cups of brown sugar for the topping. Dara has 3 and 1/4 cups of brown sugar. Does she have enough brown sugar to make the granola bars and the topping? Well, let's pretend that these are not mixed numbers. Let's just say that she needs 1 cup of brown sugar for the bars and 1 cup of brown sugar for the topping, and that she only has 3 cups. Does she have enough? Well, remember, she has a total of 3 cups of sugar. She needs 1 cup for to make the topping and 1 cup for the bars. What would you do to solve this? Well, you would add 1 plus 1, because that's how much sugar you need. You need 2 cups to make the bars and the topping, and you have 3 cups of sugar in all. Do you have enough to make the bars and the toppings? The answer is yes, because you have 3 cups. 3 cups minus 2 that you need is 1. So that's how you kind of solve this one. First, you got to add 1 and 2/3, right? You got to add 1 and 2/3 to 1 and 1/3. And then when you add those two, subtract it from the total, 3 and 1/4, right? So this should be easy right here, because when you add, I'm gonna do most of my math down here because I have space down here. When you add 1 and 1/3 plus 1 and 2/3, should be a piece of cake, because the denominators are the same. So all you have to do is add your numerators and you add your whole numbers with your whole numbers, right? Let's add the fractions first, the numerators. 1 plus 2 is 3, and then you keep the denominator 3. And then what's 1 plus 1? 1. Well, you can't leave the answer like this because that's an improper fraction. Remember I told you in the video earlier? Since the 3 is equal to the 3 at the bottom, that's improper. So it's like saying you have one whole and then you have another whole that is broken up into 3 parts, and you want 3 pieces out of 3. Well, isn't that the same thing as one whole? So technically 1 and 3/3 is the same thing as 2 wholes. You see that? Now that's how much sugar you need to make the granola bars and the toppings. But she already has 3 and 1/4 of sugar. Do you have enough to make those? Yes or no? The answer is you need 2 cups. You have 3 and 1/4. 3 is greater than 2. The answer is yes, you have more than what you need. So it's either A, B, C, or D. All right? And again, is 2 less than 3 and 1/4, or is 2 greater than 3 and 1/4? I'm going to let you figure that out on your own, okay? But I think the answer is kind of easy now, hopefully. And then let me go on to the next problem, to number 5. Let's see, number 5. Jump over here. And then number 5 says, John plans to practice piano at least 2.5 hours this weekend. If he practices 1 and 1/6 hours on Saturday and 1 and 1/4 hours on Sunday, will he meet his goal? Well, it's the same thing here. Let's pretend that this is not even a mixed number, just a whole number. He's going to practice 1 hour on Saturday and 1 hour on Sunday. But yet he plans to practice 2.5 hours on the weekend. Will he meet his goal? Well, the answer is yeah, because 1 plus 1 is 2. He has 2.5 hours already. So what I'm doing right now is I'm kind of estimating, all right? I'm also trying to get you to understand that it's simple addition and subtraction. Because some of us get scared just because we see mixed numbers, and for some reason or another we can't figure out what operation to use, whether we're going to add, subtract, multiply, and divide, and that shouldn't be a problem. Okay, remember, he's going to practice 1 and 1/6 on Saturday and 1 and 1/4 hours on Sunday. You add those two together, right? And then of course you compare that to the total amount of hours that he wants to practice for the weekend, which is his goal. So you're going to subtract from the total, right? So again, we're going to do the same thing. Now this one's a little different though, because the problem with this is that none of the fractions have the same denominator, and they all have different ones. So you're going to have to find a common denominator, what we call least common multiple, and that was a lesson from last week. All right. Now, Let's go ahead and add 1 and 1/6 plus 1 and 1/4. All right. I'm going to do it at the bottom again. 1 and 1/6 plus 1 and 1/4. You can, and I'm just going to go real quick. The least common multiple for 6 and 4 is actually 12. Because 6 times 2 gives me 12 and 4 times 3 is 12. Okay, so whatever you do to your denominator, you have to do to your numerator. 6 times 2 gives me 12, so 2 times 1 is 2. And then what times 4 gives me 12? 4 times 3. So whatever I do to my denominator, I do it to my numerator. 1 times 3 is 3. Right? Now you can add these two mixed numbers because they have the same denominator. See that? Okay, so what's the answer? Add your whole numbers. 1 plus 1 is 2. Your numerators, 2 plus 3 is 5 over 12. Okay, so that's how much he needs, right? That's how much practice he's going to put in on Saturday and Sunday. He wants to practice for 2.5 hours. Will he meet his goal? Well, let's subtract 2 and 5/12 from 2.5. Now, for those of us that are smart and can quickly figure this out, look at that denominator right there. It's 12, right? So what can I do to the 2 to get 12? Well, I can multiply that by 6, right? So whatever I do to my numerator, I do to my numerator. I hope I said that right. So that would be 2 and 6/12. What we're saying is 6/12 is equivalent to 1/2. All right? So now what you do is you subtract 2 and 5/12 from 2 and 6/12. 6 minus 5 equals 1 over 12 because the denominator doesn't change, right? And then 2 minus 2 is 0. So was he able to meet his goal? Yep, because he had enough time. You see, he had some 1/12 of an hour left. See? All right, so you select the answer, of course, and I'll let you figure that out on your own. I kind of did most of the work anyways for you, but it's okay. All right, so and I think that's it. Yeah, that'll do. All right.